Hey guys, and very welcome to this battery project that I am working with here. So I am now building this to a friend of mine, and I thought that why not just do it the right way. So I will use Dalathegreat's battery emulators together with his codes and everything. So this battery will now talk to my inverter in the basement here. As you might know, I already have a battery to my house, and that's a Volkswagen ID3 battery on 62 kilowatt hours. And I am sadly not able to use that BMS together with these emulators because it's not developed yet. Dalathegreat is working on that, but for now I cannot use my battery together with the inverter. So the BMS is not working there, but I am using that one in lead acid for now. So this is a better option, and you will have more control over your battery. So therefore I will try this out and see how it works. And yeah, a little spoiler there, it works just great. So I will start to build the electronic box for everything here, and then I will connect it to the inverter. So as always, very welcome, and I really hope that you enjoyed this one. Here we go, guys. So here we have everything. I just bought all of those stuff from Biltema, not all of them, not the Lylygos, and not this one. This is actually coming from a place called Jula. Every Swedish guys and girls knows about those stores. And so what do we have here? Well, we have one master Lilygo, or that will talk to the battery, and the other one there will talk to the inverter. And then we have this RS485 communication port that this CAN bus that comes from the battery, it will enter that one actually, and then it will be translated or converted to just some serial shit, and then it will be translated again to CAN bus and be thrown out into the inverter. So in that way it has filtering all the vehicle CAN bus, so we just now have clean inverter CAN bus instead, so this Solax inverter can understand everything. And then we have some breakers. I just have this one for to activate this phone charger that is sitting down there. So we will apply 5 volts into those boards here. And the next one is powering the relays, or I think I will have this one to the BMS, and this one will control the contactors. So Lylygos, BMS, and high voltage contactors. Pretty nice. And then I will just need a network cable that will be plugged in this one. And I have tried to make this as compact as possible. So in this network cable here, I will have a plus and negative coming out from this control box and into the battery, so I can both control the relay, the BMS, and also supply the BMS and the relays with power in one single network cable. So the BMS altogether draws 0.7 amps, so around 8 watts at 12 volts. So that's not too bad. I think that it can handle it. The relays and those in standby mode are just taking around 10 watts. So that's just fantastic. I can do some calculations on that and see how many kilowatt hours that will be in a year. I will now keep on going here. So yeah. So first I will start to solder those negative wires together. Okay, it's a little windy outside, so it can be some wind noise. So let's connect the 12 volts adapter, and then I have this connector that comes from the battery, and let's plug this in to battery. Let's start up the Lylygos first. And we have two greens, and now the first one indicates that we have some CAN problems with the battery. So let's turn on the BMS to the battery, and we are talking to the battery. The other one are now complaining that we don't have any communication with the inverter, so this red light is for now perfectly okay. So let's turn on the power to the main relay inside of this battery. Hopefully you can hear it. I placed the mic on the battery. Yeah, you probably can hear it. So I will turn everything off, and now it's time to connect everything to the inverter. So let's talk a little about the terminals here, because sadly this battery did not have the high voltage contactor, or not even the low voltage contactor either. So I have just soldered on those solar panels connector here. It's a 6mm gauge on this one here, so it should be good. It's only around 20 centimeters long, and the connectors here, I think that they are 80 to 20 amps or something. But for a short while I maybe can try 30 amps too. This is just for a test. So this will go into my basement, into the battery, and yeah, that's pretty much how I have done it. So nothing special at all. This has to be sealed up properly later on, so we don't have any moisture inside of the battery. So I will try to place this so you can see everything. Here we have the rest of the cables. So this is from inside of my basement. So this will be connected to the inverter, the high voltage negative and the positive connection that will be connected to the battery. And then probably the most important lead here is the ground wiring. It's super important to ground the battery together with the inverter, so we don't have any voltage difference here. So instead of 2.5 volt, we can have a lot higher than that if we don't ground the battery with the same ground as the inverter and the rest of the system. So it's super important, because the CAN bus interface can burn up then. So the first thing to do here is to ground the battery. And once again, guys, this is a test and it's temporary, so don't be too nervous. Or maybe it is now. It's time to be nervous, to be honest. All right. And let's now connect the DC wires. So this is the high voltage positive and the high voltage negative. But the contactors, they are not active now, so it should be 0 volts on those at the moment. And now let's apply the 12 volt and the network that will go down to the inverter. So this will only provide the inverter with CAN bus. So let's now turn on, now it starts to be really interesting here. So let's turn on the Lilygo. Sorry guys, it's so windy. And let's turn on the BMS. And we have 2 red on the Lilygo. And this is a little strange. So I do it one more time. I only had 1 green. Now the other one is green. And it should probably be red in a few moments here. Yeah. So now I need to go down in the basement. I will first also turn on the contactors. So hopefully I don't have any big boom right now. So let's do that. Contactors on. So let's go down in the basement. And as I said earlier, it's very temporary. Okay guys, this is nothing to play around with, it's super dangerous. So be careful. If you don't have the right training for this, I highly recommend you to not do this. Okay, we are measuring volts and we are plugged in to volt and not amp. Super important to check that. And this is the cable that are coming from the battery right now. So I am expecting around 370 volts or something. Yeah, 363. That's correct. So first of all, I will now turn off the inverter. So switch off. So now it's off. You can see that we now have 0 volts and you can see that the battery is connected in lead acid mode because we don't have anything in percent here. We only have the thermistor connected to the BMS port and therefore we have this battery symbol. So now I will disconnect the thermistor. And you can now see that this red light here is flashing or lit up. And that indicates that we don't have anything hooked up to it. And you can also see that the battery symbol is now gone. Let me zoom out a bit. So I'm not really sure what's going to happen now if I just connect this. Will this just start up and show the battery percent, if everything is alright, of course. Before I do that, I will just measure the CAN bus and the voltage difference here, so we don't mess anything up here. So let's put that one here. I'm not sure if you can see it. So I am now going to measure the CAN bus voltage, and I have a ground pin that I will connect my measuring pin in. So we will now measure the voltage over the CAN bus, and I expect around 2.5 volts. .2 on that one. And 2.2 on the other one. So we do not have any voltage difference, and that's good. If you have 5 or 10 or maybe 60 volts here, you definitely have something wrong, and you need to check your grounding system or your grounds. So good to go on that one. I'm not sure because when CAN bus is working, you normally will have a 2.3 volts on one pin and the 2.5 on the other one. So the high is CAN high is 2.5 and the CAN low is 2.3 ish. So let's now connect this one here and see what the display will say. I might have to go out and start up the Lilygos again so they start to communicate. I'm not sure. Here we go, guys. And nothing has happened. So I will go out and start up the Lilygos again. Okay, I had 2 greens out there now. And 50%, now it is showing up. Ooh. Great. So, okay, we had that red warning light is now gone. And you can see that we have this battery symbol with a cross over it. And I guess that's because that the battery voltage is not seen by the inverter. So let's turn on the battery in 3, 2, 1. Let's see if that crossover everything will disappear. No. Maybe I have to disconnect the BMS again. And let's apply the BMS again. And we still have the cross over it, so something is clearly wrong there. And let's turn on everything. So now it will go through its checking mode. Oh. Cell temp 5 degrees. So I will now restart the whole system here. But volt fault, that's true. Unusual idle. I've never seen that before. Okay. Now everything is off. I just have to wait for a few seconds here. I will turn on the battery again. Let's turn on the grid power again. And we still have that cross over the battery. So it's not, something is wrong here. We are into lithium. 30 amps. 30 amps. Upper limit 100%. I have to take a look at the Lilygo and see what's going on. Yeah, this is great, guys. Now it is working. And yeah, I had messed up big times. So the fault was on my side. And I did some research here and I was spending a lot of hours to my computer, and finally I just saw that I had messed up with the software release versions. So what I had done was that first of all, I had some problems to flash those Lilygo boards. So I tried a lot of stuff, but finally I was successful. But I did not realize that one board was having the 6.5 release and the other one was having 6.1, and that will clearly not work. So I have now 6.5 on both boards, and I have 2 boards because there can be some vehicle CAN bus that will slip through the first Lilygo. And by having 2 of those, you can then filter out all the CAN bus data. Dalathegreat will provide that info on his site. So therefore we need 2, and that makes everything a little more hard if you're not are used to work with stuff like this. I am not. This is the first time I work and program boards like this. I have tried some ESP devices, but not on this big scale, or what you should say. So anyhow, now it is working just fantastic. So you can see here that we now have a state of charge at 99%, and we also do not have that cross over the battery anymore. So it is working just as it is supposed to. And that is just great. So, I mean, I don't think that there is any way to build a battery to your house cheaper than this. I have done some discharge tests now during this week. I had been working on this system for 1 week. And I have to say that when I was testing it, I think it was around 18 kilowatt hour that I was able to take out from it, a little more than that actually. And I paid only 1,500 euros for the battery, and for the hardware I paid around 150 euros for the Lylygos and to the electric cabinet and the smaller parts that I had there. So way under 2,000 euros for 18 kilowatt hours. I mean real kilowatt hours now, not what the capacity has been. This is what I have in the battery. So 18 kilowatt hours under 2,000 euros with working BMS. And of course some hours work, and that's not much. So I highly recommend that. Don't forget to take a look at Dalathegreat site. He is the king of this. And I have just done what he pretty much have showed us on his both GitHub and his YouTube channel. So I really would like to give him the cred for all of his work with this board and the data and the coding and yeah, pretty much everything. So I am trying this and I am super happy with it. Thank you so much, Dala, and thank you guys for watching this video, and yeah, you know what to do. I really hope I see you next time. Take care and goodbye.